context for the discussion today on spruce budworm in Maine. I'll point out for those in the room, I do have some handouts in the back of the room that I'd welcome you to take when we break. And then also on the side there, I have a couple posters on spruce budworm. So the basics about spruce budworm. Spruce budworm is a native moth in North America, and it's present in spruce fir forests throughout Maine. It's always present, often in really low numbers. In Maine, as in much of its range, balsam fir is the preferred host of the species. It undergoes regional population eruptions, leading to tree growth loss and mortality. And this has occurred 3 times in the last century. Maine is currently experiencing significant budworm activity for the first time since the last outbreak, which ended in the late 80s, early 90s. And we're seeing tree growth loss already in areas around the Fish River, in the communities of Fort Kent and Wallagrass and Frenchville, where there haven't been treatments related to the building populations, but there will be some this year. So I always like this graphic because it illustrates well the complexity of the system that spruce budworm lives in as a native species in Maine. What you see here is the food web of spruce budworm on balsam fir. And it's an awful graphic because it's very confusing, right? But it's a wonderful graphic because it really underlines the complexity of what is happening out there in the forests. So this represents one host plant. There's 6 herbivores, so insects that are eating plant material, 66 primary parasitoids, 23 secondary parasitoids, 21 primary entomopathogens, so diseases of insects, and 1 secondary entomopathogen, and 6 tertiary parasitoids. So a really complex food web, just looking at the insects and diseases out there. And despite that, outbreaks still happen. So you have all of these natural enemies, all of these natural controls, and outbreaks still happen. So this excerpt here came from a publication from the Maine Forest Service from the period before the last spruce budworm outbreak. And it talks about how there major epidemics have occurred in 1770, 1806, all the way through to 1949. They last about 10 years with noticeable tree mortality occurring after 3 to 5 years of moderate to severe defoliation. And as I mentioned, that is what we're already seeing evidence of in that Fish River Valley and the real settled areas around Fort Kent. You can see balsam fir that are sort of at the edge of collapse. This series of maps just gives you an idea of what that progression of eruptions has looked like in the last century in Maine. So if you watch, these are the areas that were mapped to have moderate to severe defoliation in Maine. You should be able to see the years 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74. This is the year I was born. So budworm wasn't really on my mind then. 75, 76, 77, 78, 79. You can see the footprint really expands into a large portion of the state. 80, 81, 82, 83, 84, 85, 86, 87, 88. And this is what that whole footprint looks like if you put together all of those maps. That's all of the footprint of impact from moderate to severe defoliation from this insect in the last outbreak. Oops, I guess I advanced. Sorry. It is. So it shows you a little bit of what the area of the state that can be impacted by that level of population of budworm during these outbreak conditions. And so why do outbreaks happen? I would say that's a question that's still debated in scientific circles. But part of the story, and a real big part of the story that's important to this approach to management that Angela and Alex will be talking about later, is atmospheric transport of the adult moths. So budworms have this behavior where they will leave in the evening, they'll lift up into the canopy of the forest, and if the conditions are right, they'll be picked up by atmospheric currents and carried long distances and deposited in new places. Sometimes they end up as fish food, which we're in favor of, but other times they find host trees that are in better condition than where they originated, because of course they're causing some defoliation where they came out of their pupation. And so the images here are models that were produced by Canadians, the Canadian Forest Service, modeling atmospheric transport of spruce budworm based on phenology of the insect, as well as, or the development rate of the insect, as well as the atmospheric conditions, the nights, in this case of July 15th, 2019 and July 20th, 2019. The yellow symbols there are where the budworm likely landed and was alive at sunrise. The blue symbols are where they were ended by rain and also by temperature. And so they may have also survived in those cases. The red are ones where they were likely to have died when they ended their atmospheric transport. And this is some of the fallout, some of what you can see after atmospheric transport events. These are contemporary events. So the photo on the left is from 2016. It's Campbellton, New Brunswick. And the photo on the right is 2013, a little bit earlier, and that's in Rimouski, Quebec. And one of the theories about that big pileup in Quebec is that they are able to direct their landing to some extent, and those lights in Rimouski, the first thing they see after they have crossed the St. Lawrence was what gave them the impetus to come down and land in that area. And since that 2013, we have seen several of these mass transport events where moths have landed in Maine. In 2013, we had evidence in our traps that we had moths that had landed in Maine from some of those flights. And this is an example from 2021, and where we have seen moths deposited in our forests, sort of amplifying the populations that are already there, potentially increasing mating success in the future and building those local populations as well. In the spirit of providing some context, I wanted to talk a little bit about what happened during Maine's last outbreak, even though I was an infant at the time. The outbreak spanned roughly from 67 to 93, and there's some folks in the room who worked through it. There are about 136 million acres across North America of spruce fir forest that were impacted by the outbreak. And in those areas, balsam fir mortality spanned between 84 and 97%, and red spruce mortality reached between 30 and 66%. So red spruce is better able to withstand impacts from spruce budworm feeding. It retains more of its needles are not as palatable, and it's not as well synchronized with the budworm for them to survive as they are in outbreak. And these impacts to the forest also had impacts to society, and that included hundreds of millions of dollars lost in revenue, jobs, not just in the forestry sector, but also in things like tourism, recreation, and a lot of aerial spraying in order to keep trees alive. And that was following a foliage protection approach to management, where the insecticides were applied to the trees in order to keep the trees green and alive so that they could be preserved for future harvest. This is a look at what was treated during the last outbreak. So this is, again, that foliage protection program. The numbers are small in the graph, but the first bar is 1972. The last bar is 1985. The yellow is acres sprayed of BT, Bacillus thuringiensis, which I think Angela will talk more about. I'll talk a little bit about it later. And then in gray is the acres sprayed, 1,000 acres in carbamates. And in orange, it's the acres sprayed in organophosphates. And the table on the right shows you those numbers, just because recognizing it's a little bit difficult to read them from the graph. But up to 3.5 million acres a year treated for foliage protection of budworm in Maine during the last outbreak through programs led by the Maine Forest Service. And coincident with the start of that graph, DDT was banned in 1972. And with the ban of DDT, there was really a quick proliferation of other products available for treatment of forest insect pests. And so many were experimental and in early development. If you look through the white papers and also the research papers from those days, you can read about that and see, what that progression was like. There was one caterpillar-specific ingredient available towards the end of the outbreak. It was in testing phase until 1978, where the first sort of operational treatments happened in Maine, and that was Bacillus thuringiensis bacii. So what about now? What do things look like in Maine? So one of the handouts I have in the back there is our sort of forestry facts nutrition label. Shows you what we have for the forests of Maine. And in Maine, this will tell you we have over 6 million acres of spruce fir forest. That's the broad forest type. About 5 million acres of that is susceptible to damage or at risk of damage by spruce budworm. So recognizing that and seeing the high moth catches in 2013, the Spruce Budworm Task Force was formed in response to that mass transport event that was shown with the front end loader there in Rimouski. And also recognition that populations of budworm were building on our side of the St. Lawrence in Quebec. So that was a banner year in budworm dynamics in this region. We saw that mass transport event from north of the St. Lawrence, and we saw evidence of the building populations south of the St. Lawrence. And so that task force was formed jointly between the University of Maine Cooperative Forestry Research Unit, who are here today, as well as the Maine Forest Service and the Maine Forest Products Council. And they brought together a coalition of experts, some who are in the room today, who published a sort of guidebook for response to the coming budworm outbreak, recognizing that some things didn't go as well as hoped for in the last outbreak, and that maybe with preparation, we could do a better job in this current outbreak. So the first plan was published in 2016. That was long before we saw late instar budworm, the older budworm caterpillars in Maine, readily anyway in the forest. Like I said, they were always here. And then in 2023, the CFRU led an update to that response plan, and those are both available on the Spruce Budworm Maine website, which I have at the end of my presentation. And then in 2024, the landowners in Maine who own the vast majority of some of that northwestern part of the state, the large landowners in Maine, formed the Maine Budworm Response Coalition in order to be able to coordinate a response to the building populations on the regional level across Maine. And Alex is here today representing that group. And that was actually something that the authors of that first report in 2016 had recommended, recognizing that the state role would be very different in the current outbreak. And then last year, there was the first coordinated treatment response led by the MBRC across northern Aroostook County, where approximately 240,000 acres of spruce fir forest were treated, and quite successfully, which again, I think Angela will speak to later, so I won't speak about it too much. And so I've mentioned early intervention a few times, and I just want to briefly touch on it because again, Angela will be covering it a little bit later. But with the early intervention strategy approach, this is something that was pioneered in Atlantic Canada, and it was built on research that was conducted in the Gaspé Peninsula of Quebec when those populations were building, and sort of gave us that early warning. That research gave us that early warning that those populations were building on the South Shore. And the approach is a little bit like dealing with a wildfire, where you have a fire kind of raging off that you know you can't control, but there are sparks that are landing in areas sort of in the surrounding area. And so the approach is to make sure you're putting out those spot fires in order to prevent that whole area from coalescing. So it's knocking back hotspots. And the important partners in that approach are those natural enemies that I showed in that slide with that complicated graphic. Natural enemies that are so important in maintaining budward populations need to be conserved in order for the approach to work. And the purpose of the treatments is to put the budworm populations down to a level where those natural enemies can help to keep them from outbreaking. I will say that foliage protection is still in the toolbox. It uses the same insecticides now that the early intervention strategy approach does. And it's used in Quebec. And it is also probably the closest to what we are doing in areas around Fort Kent, where we're treating and it's going to help with early intervention. But those trees, if we were strictly following early intervention in Fort Kent and those areas, would have been treated 2 years ago at least. So it is still part of the toolbox. And silviculture and forest management is as well. It was important in the last outbreak. It's just important in this outbreak. It's important both proactively, which the organizations that are managing have had top of mind, as well as reactively as the outbreak impacts trees. And just the little side boxes I have there, are you covering them in any detail, the insecticides?
A little bit.
A little bit, okay. So I'll go over it just so that it does get covered. The tebufenicide is a synthetic insect hormone that causes irregular molting in caterpillars. It needs to be ingested in order to be effective. It breaks down quickly in the environment. So it is specific to caterpillars. It breaks down quickly in the environment. And it is compatible with preserving those natural enemies that are in the forest, those wasps, the flies, the beetles, the ants, the dragonflies, all of these predators and parasitoids that are acting on budworm populations. Bacillus thuringiensis, BTK, is a biological insecticide that's derived from soil bacterium. It also is specific to Lepidopteran, this particular strain of BTK, and it also needs to be ingested in order to be effective. It also breaks down very rapidly in the environment. And so Angela Meck is going to follow with more information about the monitoring and how we determine where treatments are to be used. And then Alex will talk a little bit more about the approach that is being followed here in Maine. And I have this slide up here to kind of leave up if you want to take a picture of it, or it actually comes from the sprucebudwormmaine.org website. It gives you a list of resources in case there are any questions that you have that don't get covered here. You can reach out with those questions.
We'll take questions from the in-person audience. And Allison, if you could just repeat the question.
I'll try to. Yes, sir.
What we got for natural enemies? I see a little diagram of some birds and stuff.
Yeah, so the question is, what is there for natural enemies of spruce budworm? And the answer is there's a whole host of natural enemies of spruce budworm. There's a great hand-illustrated guide that came out during the last outbreak from the US Forest Service that just covers the predators of spruce budworm. You have things like spiders and dragonflies and ants and beetles and that are the predators. And then also things like birds, small mammals, fish, it is a broad range of organisms that are natural enemies. And then the things that really kind of help to keep populations in check, it is the whole community, right? That's helping to keep populations below that outbreak threshold during, most of the time. But there are also really important parasitoids, so insects that develop within the spruce budworm as opposed to eating them outside the spruce budworm. And those are things like wasps and flies. And then there are diseases as well. Just like we have diseases, insects have important diseases as well. Important to us as people because a lot of times they help to keep their populations from becoming pestiferous.
Friends.
Wasps are one of my favorite types of insects.
The treatments harm any other Lepidoptera?
The treatments will harm any caterpillars that eat a dose that's effective, yes. So any other caterpillars that are around at the same time of budworm and feeding on the foliage where the pesticides land.
Thank you, Allison. And please hold as I alter the Zoom screen. Our next speaker is Dr. Angela Meck, who is an assistant professor of forest entomology in the School of Biology and Ecology at the University of Maine. She is also the director of the Spruce Budworm Processing Lab, which opened at UMaine in 2021. The lab works with landowners and stakeholders to monitor spruce budworm populations in New England and predominantly Maine. On that note, Angela, you're good to go.
Thanks. Thank you all for coming out today and for logging in online. So this is going to be kind of a little bit of a biology class. I'm going to give you a little bit more about the life cycle of spruce budworm, and knowing about that life cycle is how we've been kind of figuring out how we can manipulate it for this new management tactic. So as mentioned, spruce budworm equals bad for spruce fir forest, and whoever named it should have named it fir budworm because fir is its primary host. As Allison mentioned, it is native. It's a transcontinental pest. It can be found from coast to coast wherever there is spruce fir forest. And as you can see, spruce fir forest in the US is predominantly in the northern latitudes, and we have a good amount of it here in Maine. Also, it does experience these outbreaks and it has been doing that for thousands of years. So this is part of its natural behavior. There are a group of insects that do this outbreaking. And it's an evolutionary advantage. They increase their population densities so much that nothing can really control them for a little bit of time, and in this case, close to 10 years. So its generation only has one per year in its life cycle, and these egg masses are going to be tiny clusters that are laid on individual needles. So she'll lay 20 here, 20 there, about 200 eggs per female. Then when they hatch at the end of the summer, so late July, early August. This is what we refer to as the first instar or the first caterpillar stage. They don't actually eat. They just disperse. So they do this thing called ballooning, where they make a little silk strand, and just like a balloon, they just get blown in the wind. And so they disperse through the forest by just dangling on a piece of silk and being blown around. Once they land on a new host, they will molt into their second instar, and we refer to these as the L2 stage. And again, they haven't eaten at all. They have hatched, dispersed, and they're going to create a little silk home. We call it a hibernacula. And they're going to reside in that silk home for the entire winter. So basically from late August all the way through till about now. They've been just hibernating on the host, but they won't start feeding until they reach the next stage, which is the L3 stage. So it's about to happen any day now. I think we're approaching the right degree days. And the trees haven't fully broken bud yet. So during this time, they're going to be in some of the older needles mining. They might be feeding on the pollen cones until we get that new growth flush coming out. As they continue to eat and get bigger and molt through these later, bigger caterpillars, they become what we refer to as just messy feeders. They prefer to feed only on the new growth when new growth is available. So that really nice, soft, bright green needles, it's easier for them to eat. And so they'll eat part of the needles and then they make the silk and then they end up pooping in there too. So it's just this mess of brown needles and everything. And so the tips of the branches look almost scorched because the needles have turned brownish red during this phase. They will pupate in early July. And then we get that mass emergence of the adults in mid-July to early August. And these moths are very small. You can see in the picture, that's somebody's finger. They fit on a finger. They're very small. And we can tell that it's spruce budworm by these two dark bands on their wings. So they could be grayish to brownish colored, but they will have those two bands on them. And then this is what we think of with an insect that outbreaks. There's different stages of the outbreak. And as Allison mentioned, most of the time, we can't even find spruce budworm on the landscape. It is kept in this non-outbreak phase, very, very low. The building phase, normally we actually don't notice this. And that's because we haven't seen those extreme impacts yet. Just the population is growing. Then the outbreak phase is where, we now have a massive population on the landscape. We're seeing these impacts on our trees. We're seeing the mortality. Then eventually it will decline either because they've eaten all of the hosts or there's been management from either humans or natural enemies. And then they go back down to that non-outbreak phase where they'll remain for decades, kept in check by all of these natural enemies that Allison was talking about. So there is a whole cohort that keeps them in check normally. So the outbreaks do last for quite a chunk of time. In the beginning, the caterpillars are just going to be feeding on the new growth of the trees. And so I really like this image because it has every stage of tree decline being fed on. So we still have some green trees. Then you can see some trees that just have the new growth. So just those tips have been fed on, but inside the tree, it's still green. The tree will eventually stop producing new growth because it is stressed out. And then the caterpillars will feed on the older needles. So that's when we see nothing on the tips of the branches. And now we see the brownish needles on the inside of the tree. And then 3 to 6 years of that, we end up with the mortality. So we end up with the gray looking trees. And as Allison mentioned, the mortality rate is pretty high, especially for fir, but can also be pretty high for spruce. So we have not only the hot spots that sort of expand, these outbreaks that grow, but as Allison mentioned, we have these long distance dispersals that happen from other areas. And so these are some weather radar maps from 2024. This was a population that kind of came from Western Quebec and made it all the way to Maine. But a couple days later was an even bigger emergence. And this one made me glad I don't live in New York anymore. And so, yeah, so we can definitely see these in-flights coming in. And so during the last outbreak, it was foliar protection strategy was the main objective to manage budworm. And it was really about just keeping the trees alive long enough to harvest. And so the areas that were getting sprayed were areas that had high spruce budworm density populations to try and keep defoliation to less than 50%, and predominantly focused on high value stands. And so what that meant was outside of those spray blocks, the spruce budworm populations were left alone. They were able to continue to grow. They ended up running their course, causing a lot of tree mortality. And then what would end up happening is that population would re-invade the sprayed areas each year, requiring repeated spraying in these locations every year. And as mentioned, we used, unfortunately, broad spectrum pesticides. So what broad spectrum means is that it is not specific to just a particular group of insects. It would kill all insects. And so that meant that during this time, it was also killing the insect predators and the insect parasitoids. And now we know, we've learned our lessons, that that isn't really beneficial, that could actually extend an outbreak and lengthen the impacts of a pest because we've taken out some of the helpers. And so with the Quebec outbreak, starting with spruce budworm around 2008, as Allison mentioned, folks kind of had the wherewithal to know that this is going to be coming our way. And so New Brunswick really took the lead in testing a new method. And you can see this map here. It's almost as if spruce budworm got to the New Brunswick border and was just like, nope, never mind, don't want to go there. Which makes no sense because New Brunswick is beautiful and has tons of beautiful spruce and fir forest. And so the game that they were playing was, like Allison mentioned, I typically refer to it as sort of the whack-a-mole game from Chuck E. Cheese back in the day, where you would have these things popping up and then you just knock them back while they're the small sort of little embers before the wildfire begins. And so that's what they were implementing. And this is referred to as early intervention strategy. And so this is a graph that summarizes EIS really well. So in the background, you see that population growth that would occur normally with an outbreaking pest, where we have the non-outbreak phase where it's below the threshold. Then it would cross over that threshold and we have the building phase, and then the outbreak would be way up here. But with early intervention, it's catching that point right where the building phase is starting, and it goes over that threshold. So it's gone over the point where natural enemies can't keep it in check anymore. And so what they implement is through monitoring, we find that point where it crosses over the threshold. We implement a spray program and we just add a few percentage points of mortality, just enough to push it back down below the threshold where natural enemies can keep it in check and keep it in a stable population. So that's what EIS is. It's preventing the outbreak. We're basically knocking it back before it explodes. And so some of the benefits of EIS, the objective is to keep the forest healthy. So we don't want spruce budworm to erupt and to damage the trees. We want our trees to stay healthy. And this method is actually cheaper, so folks really like that because we're spraying smaller areas. So instead of waiting for the outbreak to be across thousands of acres, we're spraying just these small growing hotspots. And so somebody in Canada did an evaluation and determined for every $3 spent on EIS, it's $250 return on investment. And so that's looking at if you didn't control and you lost the value of those trees, that's the benefit. It's also more environmentally friendly because we're not spraying a huge, massive millions of acres of an outbreak. We're spraying these small spots. As mentioned, we're using the targeted pesticides, so BTK and tebefenicide, that are only going to impact the caterpillars that are feeding at that exact moment in time on those trees that are sprayed. And so a couple things that are beneficial here is that it's not impacting the wasps and the beetles and the other insects. So they're still totally okay in the system. And that area can get repopulated with our native other caterpillars that may be impacted by that spray. It prevents large-scale defoliation and mortality. So one of the things that we're targeting is that early caterpillar stage. So they haven't actually done a lot of feeding yet. So we are avoiding a lot of that significant mortality. We're able to find that growing hotspot before any sort of aerial defoliation detection would be found. Rarely 2 years of consecutive spraying. So whereas when we had a big outbreak, you're only spraying this, it's going to get repopulated. Now we're preventing this from growing. And so there shouldn't be retreatment unless there's overflow from some other area. And so ultimately, this management tactic is manipulating what we know about spruce budworm's behavior with outbreaking. So we're kind of, taking its life cycle and working with it. So all of this is extremely dependent upon monitoring spruce budworm populations. We have to find that point where it is crossing over the threshold and growing. And so during the last outbreak, the way they monitored for spruce budworm was actually to look for those egg masses. And so this is a photo of folks that were doing the monitoring during the last outbreak. And as you can see, it is a lot of women because they would gather anybody who had free time during this very short window that could help. And so it was a lot of folks from the community, foresters' wives, and everybody that could come together and help with this monitoring. But some of the issues were really short window because the egg stage is only for a couple of weeks. So they had to do the entire program's monitoring just over a couple of weeks. Big chance of human error because you are looking for these tiny egg masses on single needles of spruce and fir trees. So lots of squinting. And so we needed to come up with a new method. And so at the end of the last outbreak, they realized, well, what if we looked at that overwintering stage? And so that's the L2s. And so that's what we now use is this L2 sampling for our monitoring program. So that is the second instar larvae that is overwintering from basically August through April. And so this is an actual indication of the population that will be in that area and wake up and start feeding. Whereas the eggs, they could hatch and actually disperse out. So this is a better indicator of what is actually in the stand. We have 7 months to sample. So this is also, it gives stakeholders a little bit more flexibility. It gives us a little more flexibility. And we have enough time to plan the spray program. So getting all of this information before the caterpillars wake up in the spring. And it's relatively low cost. So when thinking about this, we charge right now $35 a site to do the processing, but most of the monitoring is actually subsidized through federal funding. So what is L2 monitoring? Landowners, stakeholders will go out to a site, they'll pick 3 trees, and they will clip a 30-inch branch, one branch from each tree, and they'll put them into our very big bags, and they'll send them to us at the UMaine lab. We take these branches, we chop them up, and we actually soak them for a couple hours in hot sodium hydroxide. And this is to actually dissolve that silk because they are overwintering in their little silk home that they made. Then we filter out so that the larvae will have come loose from the silk dissolving. We get rid of that big plant material. Then we have what I refer to as our chemistry magic phase. We have to separate the larvae from the really fine plant material. And so we use a hexane layer, which is kind of like oil and water, and the larvae float to that layer and the plant material sinks. And so we're able to sort of rinse our samples so that we have just not a lot of plant debris. And then we end up with everything on a Petri, and then we have to go through and poke through all the material, find the larvae, and identify them. There can be other caterpillars on these branches. So there's a fir coneworm, for example. And so we have to know, are these spruce budworm or are they fir coneworm? And so we have to actually, in order to ID these tiny caterpillars, we look at their anal combs. which is a scientific term. And so it's this little thing, to flick away what comes out from there. They don't want it stuck to their butt. And so they have different styles. So the anal comb on a spruce budworm looks like a crown, whereas on a fir cone worm, they have two really long teeth that kind of crisscross. And so we do all of the IDs in the lab, and if we find an average of 7 caterpillars on a 30-inch branch, that is where we contact the stakeholder and say, okay, your population is over the threshold, you have the beginnings of a hotspot, and that if you don't implement any management, you will most likely see some damage in your stand over the spring. And so, as mentioned, we opened up the lab in 2021. We are the only processing facility in the US. Canada has a handful of them all over. We started really small, doing about 300 sites a year, mainly just in Maine. We have now grown. This year, we reached almost 1,000 sites. We've added New Hampshire, Vermont, and New York. And 700 of those 1,000 sites are covered for free as a part of this monitoring program. Because in order to figure out, we sort of need to know what's going on with budworm at the landscape. So we wanted to make sure that we had part of it covered. And then if there are additional samples needed, we charge the fee for service rate of $35. And so when we first started opening, we were kind of bored. We were doing like 300 sites and nothing, it was like, okay, the highest we found in 2020 was 7.67, just barely over the threshold. And then you see 2023. So at the end of our 2023, 2024, because it's over the winter that we're doing this, we found a location, a very remote area that was turned in a little bit late. And we found some 30s, which was the highest we had seen for our averages. Then we knew that something was going on, so we hit the ground running in the 2024 season, and holy cannoli. We saw this very steep uptick in the populations where, okay, we definitely have something going on in Maine. And this was also corroborated by the Maine Forest Service, did some aerial surveys in the area that we had the 2023 come up. And as you can see, it was right along the Quebec border. And this shows the line between Quebec and Maine. And you can see that probably what we had going on was spillover from Quebec's population coming into Maine. So that we estimated about 33,000 acres in that 2023 season. And in 2024, that grew to over 300,000 acres. So very quickly, within a year, the spruce budworm population that had just started to kind of cross over the threshold really skyrocketed quick. And so this is zoomed in what we had last year. So at the end of the 24 season, so this would be spring 2025. Every point on here, every circle is a monitoring site that was submitted to the lab. That data is then used by my colleague up at UMaine Fort Kent, Dr. Neil Thompson. And so he plugs all of that into a spatial model that kind of connects the dots and figures out what the population densities are most likely at based on all our monitoring. And so you can see that there are definitely the very high zones. We had some sites that on 30 inches, we had over 130 larvae on it. So that is an extremely high infestation of budworm. We also had these two blocks. So we have the western block on the Quebec border and then this eastern block near the Fort Kent area. And so that data was then used by the coalition to develop their spray maps. So they took, so I can kind of go back here. So we had that, they got this map of where the populations were most likely above the threshold, and they designed their spray map based on it. And so of the 300,000 acres, about 250,000 were sprayed, and Alex is going to be talking about that next. And so kind of that was spring 2025. Kind of the initial, how did this go? How is it looking? Looked very good. So the areas that were sprayed through early intervention strategy had green forests. We didn't see that significant defoliation, but in areas right next to it that were not a part of the spray program, you saw that defoliation. We also, in the areas that received the spray treatment, going back out a few days later, found dead caterpillars that had been feeding on the sprayed foliage. So this was all really good. Everything is looking very promising. And then we started this year's processing season. So in August 2025, we received our samples for this upcoming season. So this is what we had last year before the spray program. And then this is where we are this year. And so we have had a threefold decrease in spruce budworm populations following early intervention strategy. And if I overlay the spray maps, you see that it's beautiful. That the areas that were a hot spot before and treated are very much no longer a hotspot area, and the locations that did pop up were outside that spray zone. We did have only 4 sites that are hotspots this year that were sprayed last year out of the 250,000 acres. But the maximum number of L2s is still pretty low. Like within the spray block, the maximum L2 we found was 11.67, but outside the spray block, so in areas that were not a part of the treatment, they are closer to 100 caterpillars per branch. So again, this is also supporting the efficacy of EIS. Then we now have data from our 900 some odd sites from this year. So we're able to take all of our site data and separate it out into these 4 sort of zones. So the sites that were sprayed, we can now look at last year and this year's data to look at the difference. Then we were also interested in this perimeter. So about less than 1 kilometer from the spray block. So it's this unsprayed right along the boundary. And then going out a little bit further, so 1 kilometer to 5 kilometers, which is basically a few miles out, and then far away from the spray block zone. And so we were interested in how has it changed from 24 to 25? And we saw a 94% decrease in the average L2 counts in the spray block, which was, I think, better than any of us were expecting. We would have been happy with 75%, but to see 94 was great. And then what was really interesting was that we had an 81% decrease in spruce budworm populations in that really close perimeter area. And so our hypothesis with this has to do with those natural enemies. So inside that spray block were all of the natural enemies of spruce budworm, but we took out most of the spruce budworm, and so they have shifted out. And so they're basically helping us in unsprayed areas by now adding more pressure to the budworm populations that weren't sprayed. So we had over an 80% decrease in that zone, in that unsprayed but really close to the sprayed areas, which is really good. Then in the unsprayed, we saw an increase in budworm. So this is telling us that the decrease we saw in the spray block was because of the treatment, not because of environmental factors or a cold winter that knocked back budworm. That budworm was still growing and would have grown without EIS. So all of this was just very exciting with our first year of EIS and the results we're seeing. And so this is just the beginning of what will be a long road. We know that this is a 10-year battle against budworm at least, but that these results are very, very promising from this 1 year, and that if we can continue to do it, we will hopefully be able to continue to keep Maine's forest healthy. So with that, I have a bunch of all of the staff and students who've worked in the Spruce Budworm Processing Lab, Neil Thompson up at Maine Fort Kent, who I wouldn't be able to do all of this work without. And I can take any questions you may have. Thanks.
We know much about what triggers the 40-year outbreaks.
Like Allison mentioned, it is highly debated amongst scientists. It's sort of one of those things. We have a lot of insects that do this. So brown tail moth outbreaks every 10 to 15, forest tent caterpillar outbreaks. Oftentimes they can be triggered by climate. So pine beetle, southern pine beetle, mountain pine beetle are usually triggered by drought because that's when we have stressed trees. With budworm, they took out so much of the spruce and fir, they needed to almost wait another 30, 40 years before there's enough of a food source for them to be able to handle an outbreak. So I'm sure that plays a part into it, but just specifically, it is a unique phenomena that Mother Nature has figured out with spongy moth. When that one outbreaks, the female, something triggers them to lay, instead of 100 eggs per egg mass, they lay 1,000 eggs. So it's just, they are triggered to just increase their population density very quickly. But the exact trigger is still unknown. Yeah.
So will you be mapping the progress of your EIS from year to year on your website?
I assume so, yes.
If you go to the website, we can find out how far things are advancing.
Yeah, so all of the maps with all the dots and the population model with the red, orange, and yellow, that is updated every week during our processing season. And so you can check that constantly. And then I assume we're probably going to be storing historical maps of, yes, they're nodding yes. So yeah, we're going to be definitely keeping an archive and look so that folks can look at the trends and how, look, it was really bad and now it's nothing. So yeah, we're proud.
Research. Research.
Oh yeah, and research. Well, yeah, of course. My lab is going to be doing a lot of research and analyzing all of this data and showing with the numbers that yes, it is effective, highly effective. And then we're also looking at the natural enemies effect, that hypothesis of them extending out to see if maybe we could reduce the spray area because natural enemies might be helping us more than we thought. All right, thank you all so much.
Thank you, Angela. And I'm just pulling up our final presentation before our panel segment. Yours, Alex.
It looks familiar.
All right, our final speaker before the panel is Alex Ingraham, who is the chair of the Maine Budworm Response Coalition, an alumnus of the University of Maine School of Forest Resources and president of the Pingree Associates.
That was short. I use what you give me.
Appreciate it. So good morning, everyone. So I am between you and escaping for food, so I will be probably a little briefer than Allison and Angela, but I'm going to talk today about 2025 operational activities, what happened last year, what was the reasons for success, went into how we were able to manage 94% efficacy. And then we're going to talk a little bit about 2026, the planning that goes into putting one of these programs together, the real high importance on the data collected that Angela processes that she has talked to you about, and then a little preview of what our plan is for 2026 that we're going to be implementing in a few weeks because it's spring, supposedly. All right, so this is what we did last year, and I'm going to start with our final plan map. This shows about 10 months worth of work all in one slide, so I don't want to neglect what goes into doing this. So this includes all the L2 sampling that Angela and her team did in 2024, that 25 treatment plan. This includes all the GIS work, all the collection that happens of the L2 samples from our foresters, our partner foresters in the coalition, and the collective work of landowners in the state of Maine and the Maine Forest Service, IF&W, our federal delegation, and getting us funds for doing this treatment and implementing EIS in Maine. There was a ton of activity that happened between a phone call in August of 2024 that alerted us to, there's a problem, to implementing the plan that you see in front of you in 2025. Massive amounts of logistics, massive amounts of effort that went in across DC, Augusta, and in the forest. Really, really important, and Orono, can't forget Orono. So this is a really short slide to discuss a lot of work. And what this map is showing was the final treatment blocks along with the public block points so that we do not allow the public to be in the treatment areas during treatment, just for safety protocols with aircraft flying and following all label and legal requirements associated with doing a treatment plan such as this. So last year, we treated about 242,000 acres with a mix of tebufenicide and BTK. That you heard about earlier from Allison. The total application cost was roughly $45 an acre because we did this with a lot of fixed wing aircraft, which are at scale cheaper than helicopters. This year will be a little bit different because we're using primarily entirely helicopters. This was a partnership reimbursement program through the U.S. Forest Service, thanks to emergency appropriations funding from Senator Collins. So thank you, Senator Collins. And was a cash match of 10% for the costs, but in-kind contributions upwards of 25% for the total cost. So our company, for instance, had a total match of around 45%. So a lot of heavy involvement, a lot of time that goes into this, and a lot of logistics. The most important thing that we did last year, besides the one-year results, is we created a blueprint for years to come to make sure that we continue having successful outcomes and continuing to keep the budworm population at a reasonable endemic level that you heard about from Angela and Allison. The goal is not to eliminate budworm. The goal is to mitigate the effects of budworm on an outbreak scenario. The cost effectiveness of this program, as Angela mentioned, if there was a large outbreak in Maine, it would be probably around $800 million of annual economic damage to our forest economy. Through this program, we are effectively treating that at a price tag of $10 million. So very, very cost effective and really good blueprint. And we're looking forward to continuing to do this program in a highly effective and highly targeted way. This is a scalpel approach. This is not the more broad treatment that we did in prior decades with better tools and better research. So long story short, this is what we did last year, and this is how we did it. So we now go from 10 months worth of work to now we are 5 days before a treatment program. So in order to effectively treat the budworm, you have to do it at the right time. We talked a little bit about the time impact. There's a window to effectively treat the spruce budworm. It's about 3 weeks in late May, early June. So very, very tight planning window to treat 242,000 acres. So in order to make sure that the chemical is effective and has a good efficacy, you got to time it just right. This is not a Goldilocks. This is a Goldilocks scenario. This is not a, you can have a little buffer here and there. And so the way that we do this is before the program starts, we are actively monitoring what the fir and white spruce new needle growth looks like. So if it is as tight as a fist, it's not ready. As the fronds of the needles start releasing, as you're seeing in these photos, that means that there is good open needles for the application to land on and stick to, and the bugs are then actively feeding. So the second it starts getting out a little bit and hits this threshold of about 3.2, 3.5, the magic number is 4. It's on a scale of 6, I think. 6, let's go with 6. Then, nope, 5, it's on the bar, never mind. I can read it. So when it hits 4, that is the optimum time to do a treatment. So you need to be ready right at about that time to hit the go button. And so this is a map and a tool that the Maine Forest Service developed for all the cooperators in the MBRC to utilize. There were 6 active members that were treating last year across these 242,000 acres. All of us were cooperating together, 6 different companies, one of those being the state forest, the Maine Bureau of Parks and Land, all working together on one common goal, and all of us looking at the same data at the same time and making sure that each collection that is being shown with folks are holding the samples against their hand or a paper to see the needle development, that is a key element on the time of go. And it was verified by all the entomologists on the Maine Forest staff, Maine Forest Service staff, and I believe Angela and Neil were also paying close attention to this as well, to verify that what was coming up as samples were truly and accurately portrayed at the right number. All this being said, we had high confidence that when we hit the go button, we were doing it at the right time with the highest chance of success. This is the process we're going to use this year as well, and is a really, really effective tool. So in the field, what are we looking for? We have overkill of sampling going on here on the right-hand side of the page, 4 of us to look at one tree sample. So Neil Thompson is showing us how to check this, and then 2 of the company foresters that were cooperators are doing this. And then on the left-hand side, that would be this thumb right about here, and you can just see a little squiggly line. That's a budworm that is actively feeding, and that is the perfect time to say, okay, we are ready to treat, and this was the day that we decided that and verified that treatment was a go. So once we have decided that, we are now in active treatment mode. We have our contractor has arrived. We had 8 fixed-wing aircraft last year at the Frenchville Airport, and then 3 helicopters that were stationed there as well as a command center. So this was a everyday monitoring, everyday phone call, making sure there was high amounts of coordination and logistics taking place on a daily basis. So really, really incredible crew and team that came together on this. And I can't emphasize the cooperation among landowners and the state agencies and the federal delegation was just really impressive. So that gets us to active treating. So here we have a photo from flying above the treatment. They're flying at pretty low elevation, about 75 feet above the treetops at a few miles an hour, 160 or so. And all GPS guided and controlled for when the chemical is on versus off to ensure that we're accurately hitting our buffers for streams and water quality. We're doing 100-foot buffers, which is 4x the label requirement and state requirement to ensure that we are having really good, accurate buffers and high efficacy. This is where we are really excited about the research that Angela and her team are doing to see what the natural enemies are going to have effects on the population going forward. So if we have the ability to increase those buffers because we're showing such high efficacy, fantastic. That is something we are all excited about doing. So what this is showing is the same stand, and on the left, they're flying over it and we're at a weird angle, so we're not directly overhead. So you're shooting off to this photos I took. And then on the right, you can see where the hard shutoff is the second that plane crosses over from a spruce fir forest into a hardwood forest that is not part of the treatment program. Angela showed this in her slide deck, but I just want to reemphasize this. This is how precise these treatments are. Like the area on the in the center where it was treated, and then the areas adjacent to it that were not treated. And you can see the visible impact of treatment versus not. On a landscape scale, we're looking now at the Fish River corridor. This is an area that Allison pointed to earlier where we're getting high defoliation in the state. This has been happening for multiple years. It's the biggest hotspot that remains. In fire parlance, this would be the urban interface. And so it's a little more challenging to treat smaller landowners, but we are implementing that this year, which we're all very excited about and looking forward to putting this out to landowners and making it available for everyone. So you're seeing high amounts of brown and gray trees in these areas. This is an area that was not treated in Maine, showing the negative impacts of budworm infestation in our state. Looking to our neighbors to the north and west in Quebec, there's high amounts of tree mortality and foliage being consumed going on across the border in Canada. This is directly adjacent to the Maine border. It's visible on the horizon. And so right adjacent to us is still severe outbreak. This has been going on since heavy outbreak since 2008, and the early infestations started in Quebec in 2003. It's important to mention that early intervention as a strategy was not really thought up until the early 2010s. And so Quebec didn't have a chance to roll this out as a treatment philosophy. So they are stuck because they have a 33 million acre outbreak with foliar protection because they don't have any other options. It has progressed beyond the ability to do this with early intervention strategy. In Maine, this is in our treatment block. This is actually right over some of the highest density L2 counts that we had in 2024. And you are seeing very green, very healthy looking forest below. The areas where you're seeing gray is in the buffer zones. And that's where we are leaving stream corridors, and that generally tends to have older age class species in there as well. So this is a repeat of Angela's map, so I won't walk through what's showing on the right. I have a purple color scheme. She had the green one. So it's the update's great. So what we're showing here is that overlay, really important to get out with our pace of L2 sampling this year, and the pace of the lab was much faster than previous years, more samples, higher confidence getting into December, which allows the MBRC the time to plan and plan more efficiently and narrow in what we need to do and when. So this is really important from a logistics standpoint. We have been refining this plan for months now. It has been a much more blueprint that we created last year. We are running that program back this year. And I would say it's been very, very refreshing and not as much of trying to build the ship while sailing it type mentality that we had last year. Back again to kind of a regional context, Quebec is doing something. This is not a Quebec is doing nothing. They are taking that foliar protection strategy. They're treating about 2 million acres a year with BTK. So huge amount of program cost going into this, but they're treating 2 million out of a 33 million acre problem. Original discussions with them were that they weren't going to be treating too much right adjacent to us on the border, but they ended up treating a significant amount of acres near us in the Maine border. This goes to help our overall program in Maine. This is a great sign of cross-border cooperation, just like we have with New Brunswick. And so we are keeping the dialogue and discussion open with Quebec on an annual basis and working together to try to curb this, the impacts of spruce budworm. So they still are dealing with that high outbreak. It will continue to influence our western boundary. But the steps they took that are shown in black here, along with our treatment from 2025 in black, is really good progress towards a combined goal of ending this outbreak sooner rather than later. Lastly, this is our plan for this year. And I'll walk through the bullet points on the left first and then explain what the purple things are on the right last. So really, we're building upon the blueprint of last year and the success that we saw with the early intervention strategy. This year, it's a much smaller program, 68,000 acres compared to 242,000 acres. It is across the same amount of landowners, but different cooperators this year. Some landowners were not impacted by budworm this year that were last year, and there are new landowners that are impacted this year that weren't last year. The same mentality is continuing, and that is cooperation across all landowners, both state and private, and small landowners as well, where we're all working on a common goal of making sure this program is successful, safe, and keeps Maine forests healthy. Application costs, because we're doing this with helicopters this year. Helicopters there's a lot of moving parts, a lot of moving pieces, far more expensive than fixed wing. But because of the diverse locations and smaller block sizes of our budworm population this year, we are using helicopters because it's the right tool for the job. We're continuing to advocate for both federal and state support of this program because we feel it is vital for the Maine economy. And from a dollar invested standpoint, it is a lot better than the foliar protection strategy that would cost a lot more, or letting the bug run its course, which is going to have significant impacts for the health of our forests and could create a higher potential for wildfires in this state, which none of us want. Lastly, we're trying to, as we are doing today, continue being really open and discussing this program with the public, trying to keep everyone informed, particularly in the region where it is active, but also generally as a state, where we have these information sources that Allison is showing that's all publicly available. We are sharing map plans, and this is a key reason to the success of the program, making sure that everyone is aware of what is going on, questions are answered, and that we can continue to grow the program to be more successful over time, and keep it running and make sure that we're keeping Maine's forests healthy, both from an economic standpoint, but more importantly, from a forest standpoint. So lastly, and I skipped over this bullet point on the left, we're implementing a small landowner treatment program this year. This is something that takes a lot of logistics. Allison and the Maine Forest Service team has been working diligently on this since early in 2025, as we were beginning to ramp up the large treatment program that happened last year. There's state funds that are dedicated to allowing this to happen. So it is important to keep those in the future. And so this is rolling out onto roughly 3,000 acres of small landowners in 2026. And there was an open enrollment period that was out and available, and a lot of public interfacing that went on that Allison and her team has spent a lot of time on, Brittany as well, and several others that aren't here in the room today. Really want to commend you all for the amount of work that's gone into this, because I know how much goes into planning with the large landowners, and small landowners have their own unique challenges as well. With small parcels, boundaries, we as companies all know our boundaries and have files associated with them. That is not necessarily the case with personal woodlots or backyards, a little bit different animal. So on the map, getting to that finally, the green is the acres that are being treated through MBRC program. And then in the purple zones, the darker the color purple, the more small landowners that are being treated in that hexagon. This is being shown in this way because this is private individual data sets that are not allowed to be publicly available. So we are ensuring that privacy is being kept most front of mind, but also trying to show on the map where the impact is without being without getting into that issue. So really good solution here is to show the hexagons, so where the treatments most likely are going to be occurring, and proximity to towns. So with that, I think we have questions for me, or we can just shift right into the panel and have questions for all.
Do you have any quick specific questions for Alex, and then we'll shift to the panel? All right, we'll go with panel.
All right.
Any questions for anybody up here on the panel? We'll take some in-person ones first, and then Eric has been collecting some that have come through the virtual audience as well.
Probably starting with Alex. I'm just curious, I know, he's really involved with the Maine Budworm Response Coalition last year. And curious, like, how many more landowners have started to participate, or who you're in conversation with after seeing success of last year?
Great question, Regina. So Regina asked, after last year's success, how many folks from large landowners in the state of Maine have joined MBRC. So we have almost 8 million acres of forest land in Maine that is now an MBRC member. And so this is pretty much the entire scale of forest land that is actively managed by companies or large families, and comprises most of our industrial timberland in Maine. We're obviously working very closely with the state of Maine, both the Bureau of Parks and Lands and Maine Forest Service.
Carol.
As I understand it, the money that the state legislature approved last year was going for the small landowners issue. So did the state pass additional funds for next year?
So I'll cover part of that, and I'll let Allison answer the specifics. So the funds that were passed last year are cover this year's program costs. And there was not a push to get additional funding this year because of the availability. So that is something we anticipate working on from an advocacy standpoint once we have a little more knowledge past November, because I believe it's an election cycle for our governor this year. And so we're going to be working on that come fall. So yes, it will be happening, but right now there wasn't a need and didn't.
I think that covered it. Did you? Okay.
Yeah, that's fine.
Follow-up question to Carol's. So EIS is working and our blocks are getting considerably smaller. How do you expect the approach for advocacy on a federal level to change as our problem is becoming smaller because it's working?
So question was advocacy at a federal level. How is that going to change as EIS is successful and if we continue success? So what we've experienced in New Brunswick, and Angela can probably talk about this better than I can, but I'll give a broad and discussion and let her follow up, is treatments in New Brunswick have been lumpy. There's been years where it's very, very high, like we experienced last year with 242,000 acres being treated, and then a significant drop off the following year, which
we also experienced. We hope that that trend can continue into next year and our treatment areas will be smaller. That's the hope. But we do not know what weather patterns are going to be. And so the inflight of moths with females laying as many as 200 eggs per egg mass, that can change population dynamics overnight. And so it is really important that we continue to advocate for federal funding of this program, advocate for the Forest Service, U.S. Forest Service to be an active, engaged member on this program. And so it is a continued effort. Senator Collins has been really, really instrumental in helping to have this happen, and other delegation members have been really supportive as well. Senator King, I update regularly both of the senators on this, and then also our Congressman Golden and Congresswoman Pingree. And so it is a really key piece of advocacy, and right now we're doing well. But weather patterns could put us back into a massive outbreak again if the wind blows over Maine as opposed to blowing it out to sea where they are all fish food.
I'll just kind of reiterate that the insect populations aren't the easiest to predict. And that, you know, we're basically going to be dealing with this, we expect, for at least a decade. Folks have asked, like, how long are you going to be doing this? But as long as Quebec's population and now Ontario's population is growing, it will continue to be a problem. It's not going to be a one and done fix for a while. And so having that advocacy, knowing that there is going to be something, even if we don't know the size of it, you know, what next year will look like, we do know there will need to be something for next year, even if it's just the monitoring.
Yep.
Can I just follow up on that?
Yeah, one last thing, and before you follow up on that one, Carol, is we also are trying to work very closely with our cross-boundary relationships in Canada, because what they have in Quebec especially is what we're potentially going to deal with. So where we can work together, we're already doing this with New Brunswick on a yearly basis. But also we're doing that with Quebec now.
That all sounds great. I'm just thinking, it sounds like you're not going to use much of the $10 million that the senator already secured for this year. And of course, we're planning to put, I don't know how much, but a lot for under the FY 27. So, and we're doing that now. So, we need to talk about what should be in the FY 27. And those kind of arguments, we need to figure that out.
Yeah, it's just discussion on appropriation season in DC is going on right now, and make sure the dialogue is continuing. And that is something that we are working closely with our delegation on, and also with the USDA and US Forest Service to make sure they're aware of the ongoing problem of spruce budworm and the threats that it poses to Maine's forest health and forest economy. Any other questions?
How do you guys if Canada treated 2 million acres last year, we treated 250,000 acres, how do you tease apart the 94% success? How much, if you talk about all of the downwind effects, if Canada did that, you know, much more, 8 times the work, how much credit do we give to Canada and how much is
30%? Well, the population that got treated in Maine, we knew what that population was sort of after the fact. So it didn't matter what Quebec was doing because we were looking at the L2s after an in-flight. And so it wasn't based on management per se. Also, there's usually a lag period with the in-flights. We don't see an instant 132 L2s on the branch. We see it usually a few years later. So the populations that were sprayed near Quebec were most likely a growing population that had existed regardless of what management was occurring in Quebec, I would assume, but Allison may have one.
Yeah, so the map that Alex showed with the treatments that were adjacent to Maine, and then the treatments within Maine, Dr. Neil Thompson, he put together those maps and provided a summary of the analysis. And approximately 30% of the area that would have been eligible for early intervention strategy treatments in Quebec were treated last year in that region. And in that same region of Maine, approximately 90% of the area that would have been eligible for treatment were treated. So that kind of gives you a picture of the I guess, comparative impacts of those treatments and their effects on the results.
Yeah, and that 2 million acres that Quebec treated, only a portion of that was adjacent to Maine. So a lot of that treatment actually occurred out towards the Ontario border. It wasn't necessarily all right in our region. So they treated 6% of their problem. We treated 90%. Other questions?
Yeah, we got one online. Based on the information provided, what steps should be taken if one suspects areas of infestation on a small scale? Should images be sent to the lab or should a request for site inspection be made?
Question. Do you want to repeat the question?
So the question was what to do if you suspect that you have spruce budworm damage on your property. So the best thing to do would be to reach out to the Maine Forest Service. And the easiest way to do that is through our online form. You can attach photos on that form. Our website is maine.gov/forest health. Or you can reach us through email, which is one word foresthealth@maine.gov. And folks will respond based on that inquiry.
And we have time for one more online. No more? No. We have time for one more in person. I will take it back then. With that, thank you, Allison, Angela, and Alex for your presentations and for answering our questions today. And thank you everyone joining us live, both in person and virtually, and for those watching this recording at a later date. That concludes this 2026 edition of Keeping Maine's Forests Spruce Budworm Public Information Session. We appreciate your attention and interest in this important topic, and we'll see you in the woods.
Thank you. Nice job thinking of future viewers. That's very thoughtful. I appreciate that.
I know the webinar game too well. I'll register and then never show. Never show.